Hey everyone, and welcome to The Explainer. I am so excited you're here today because we've got an absolutely incredible journey lined up for you. We're going to explore exactly how nature builds its most complex structures, and we're taking a trip all the way from the fiery, pressurized center of the Earth right down to the microscopic living cells inside our very own bodies. So let's just dive right into it. Have you ever wondered how our planet actually constructs a massive, flawless jewel? I mean, it's a huge mystery, right? When you're looking at a beautiful gemstone, you are actually looking at a mineral crystal that formed super deep below the surface of the Earth. And these things, they don't just magically appear out of thin air. They need a very specific, almost perfect set of conditions to grow. Section 1. The secret to large crystals. From the kitchen to the Earth's crust. To understand our first major architect, which is intense geological heat and pressure, we really don't need a fancy high-tech lab. You can actually set up a super relatable experiment right in your own kitchen. If you heat up 3 cups of water and completely dissolve a couple cups of sugar into it, you've basically created a mineral-rich fluid. Well, sugar-rich in this case. You pour that mixture into a jar, drop in a wooden stick, and just step back. As the water cools, crystals will start to appear on the stick. But here is the absolute secret. The slower that mixture cools, the larger those crystals are going to be. Time and a slow cooling process are literally the keys to growing massive crystals. Keep that in mind as we look at how the Earth does this on a much, much grander scale. Now look at this stark contrast between magma and lava. We tend to throw those words around interchangeably, but for crystal formation, the difference is everything. Magma is melted rock trapped way deep down inside the Earth. It gets hotter than 1,000 degrees Celsius, but because it's so heavily insulated underground, it cools very, very slowly. And that gives those mineral crystals the time they desperately need to bond and grow large enough to be seen clearly by the naked eye. On the flip side, when that exact same molten rock erupts onto the surface, it becomes lava. Lava cools rapidly in the open air, which means the crystals simply do not have time to form, and you end up with microscopic structures. So speed and location dictate exactly what kind of rock we get. To really hammer home our focus today, this slow, pressurized underground crucible is exactly the recipe required for nature to cook up those massive gems we all love. When mineral-rich fluids meet this boiling hot magma, they percolate at extremely high temperatures. As the magma slowly solidifies deep in the Earth's crust, the elements finally have the time to bond perfectly into crystalline structures. Eventually, that forms beautiful, large gemstones like quartz, beryl, and rubies. Literally, without magma's slow cooling process, large gemstones just wouldn't exist. Moving on to Section 2, plate tectonics and magma, the engine of creation. If magma is the oven baking these giant crystals, we need to zoom out a bit and look at the massive global engine generating all that heat. That engine is plate tectonics. As Earth's rigid tectonic plates move over the semi-molten layer underneath, they interact in 3 main ways, and that generates the magma and hydrothermal fluids needed for minerals to form. When plates pull apart at divergent boundaries, the mantle melts, and we get minerals like olivine and pyroxene. When plates violently smash together at convergent boundaries, we get intense mountain building and subduction, which gives us quartz, garnet, and massive copper deposits. And finally, when they slide past each other at transform boundaries, we see fault-controlled systems full of quartz and sulfides. So different tectonic collisions and separations yield completely different mineral treasures. All right, Section 3, Earth's epic mineral evolution. A journey through geologic time. Let's see how this all builds across the vast expanse of geologic time, because the incredible diversity of minerals we have today definitely didn't happen overnight. In the super early universe, there were essentially 0 minerals. It all started with just about a dozen pre-solar minerals, things like diamond and graphite, which formed in the ejecta of supernovas. As our solar system took shape and planetary accretion heated things up, we jumped to about 250 minerals. Then, billions of years of that plate tectonics and magma recycling we just talked about bumped that number up to around 1,500. But to get to the thousands of unique minerals we have today, Earth actually needed a completely different kind of architect. Just look at this staggering fact. Over 2/3 of Earth's 5,400 plus minerals are actually the result of chemical changes mediated by living organisms. That is just mind-blowing to me. The introduction of life, and specifically the Great Oxygenation event, driven by early photosynthesis, completely revolutionized the physical geology of our entire planet. Which brings us to Section 4. Biology builds minerals too. The living architects. So we are shifting our focus completely here from the fiery magma-filled mantle up to the biological world. Biology basically takes over the job of creating minerals where magma leaves off, and it does this through a process called biomineralization. Basically, this is the complete conversion of organic substances into inorganic derivatives by living organisms. It's an incredibly widespread phenomenon, and you can find it in all 6 taxonomic kingdoms of the Earth's biosphere. The crucial point here is how living organisms engineer unbelievable strength into these biological structures using minerals. Take the mollusk shell, for example, specifically the nacre part of it. It is made of 95 to 99% crystalline calcium carbonate, combined with just this tiny, tiny fraction of organic proteins. Yet, the resulting composite material has a fracture toughness about 3,000 times greater than the mineral crystals themselves. We also see vertebrates binding calcium phosphate to give their bones rigidity, and microscopic sponges building these beautiful, intricate shells out of silica. The sheer level of control that biology has over mineral growth, literally from the nanometer up, is simply astonishing. And that leads right into Section 5, mimicking nature's biological designs, engineering the future. Because these biological architects are so flawless, human technology is now actively trying to copy them. Just like mollusk shells or highly engineered composites, cellular membranes have evolved flawless biological water filters over billions of years. We call these aquaporin proteins. They exist in all living cells, plants, animals, us humans, and their single job is to selectively transport water molecules straight through the cell membrane while keeping absolutely everything else out. They are, for all intents and purposes, nature's perfect built-in water filter. To really wrap your head around how perfect they are, look at this metric, 700. Just 1 single gram of natural aquaporin proteins can filter a staggering 700 liters of water per second, literally per second. And this brilliantly illustrates why biomimicry is the future of engineering. When you compare a standard square meter of a synthetic man-made membrane, it filters roughly 50 liters of water per hour, and it requires a ton of energy to push that water through. But by creating biomimetic membranes that incorporate a layer of these natural aquaporin proteins, a tech known as aquaporin inside, we can achieve rapid, high-performance water purification that drastically reduces energy demands. We are literally taking nature's own technology and putting it to work for us. So we've seen how the incredibly slow, intense cooking of magma deep underground perfectly engineers the most massive and beautiful crystals on Earth. And we've seen how the careful, microscopic evolution of living cells engineers materials that are 3,000 times stronger than rock, alongside water filters that completely put our best synthetic versions to shame. Nature truly, absolutely is the ultimate engineer. The only question left is, what incredible natural design will we mimic next? Thank you so much for joining me on this explainer today. Keep observing the world around you and never stop learning.